Hello, everyone. Today I'm going to be going over the Arduino IDE and microcontroller, so you guys know. And basically, here's our social media information again, if you want to join any of them. And today, as you can see in the schedule, we're going to be going over the Arduino, and that's used a lot in EE186. Oh, looks like, hey Nathan, what's up? We're going to be going over just Arduino today, and I'm going to be telling you guys a little about it. And so, what is a microcontroller to start out? And so a microcontroller looks something like this on the right. We have pins, inputs here that you can plug into on both sides. And basically, you can attach it to your computer through this USB port and get it to run. So you can put in specific inputs and get outputs. And so that's the cool thing about a microcontroller is a lot of the times you'll see it's called the IO is a common reference, which is input output pins. That's what it stands for. And so it works as a small computer. And basically, it has a processing core, memory, and programmable inputs and outputs. And so we have a processor in order to process the information to synthesize it. We have memory and we have our connections. And so looking at the Arduino here, the most popular ones you'll see when you use are these digital pins. So we have 13. So it goes from, if you look at the board, it starts here at 0 and goes all the way up to 13. And then we have a ground, and you'll notice some of these have little wave symbols next to them. That means pulse width modulation for a duty cycle. So how much the voltage is applied. So the voltage might occur here, be high, and then the voltage will go back down and be off, then it occur and be high again, and then go back off. So those are pulse width modulating pins, which mean that the voltage is not consistent. So it's not at one constantly. It will sometimes be on and sometimes be off. So 50% of the time it's on and 50% off. So we would say this has a 50% duty cycle. And so also on this Arduino board, what I want to point out to you guys is there's TX and RX. And so TX stands for the transmitting and RX stands for the receiving. And we also have a reset button here. And there are capacitors here. You'll see when they stand out, they look a little like this. So that's one of our basic circuit elements. They can just store charge. That's the basic role of capacitor. And on the other side, you'll have analog pins. So analog is like me talking to you right now. It's continuous. And then we also have power pins over here. So a 5-volt power source, a 3.3-volt power source. Then we have ground pins also on this side. And so the Arduino, we'll get into more of it, but it's basically all you need to remember is it has inputs, outputs, and functions as a computer. Okay, now we're going to be talking about microcontrollers a little more in depth between the Arduino and Raspberry Pi, because you'll hear about these a lot. And so for an Arduino, it is based on C and C++, the two coding languages. And there's an Arduino Uno, which is smaller. You can see in this diagram. And we have an Arduino Nano, which is really just your basic. It can do all the same functions as the Uno, but it's smaller in size. And then we have Raspberry Pi, which is more of a microprocessor, not a microcomputer. It can do a lot more, so that's why people use it, and you'll see it. It has an HDMI port here, the Arduino doesn't, and there's another USB port. And so you can code in any language for Raspberry Pi, so that's the benefits over the Arduino. But for your introductory classes, you'll primarily just be using this one. I haven't heard of anyone using Raspberry Pi. And those are just two types. And now I'm going to get into the breadboard. So this is going to be a little of 201, and you'll see why I'm talking about the breadboard with Arduino. So for the breadboard, you need to notice it has holes throughout it. There's a, There's a hole here, here, here. They're all along this board. And basically, we have columns and rows. We call this, oh, you have a question? Oh, can you help? Okay, yeah, this is gonna be a little good intro for a 201. So let me just get through this real quick. And then I might be able to help at the end. I have class at 4, but if that works. So we have the columns here because they retain the same voltage across. So we have the columns all down here, have the same voltage. We have two, one for the positive terminal and one for the negative terminal. And then we have the rows here, which are connected horizontally, we'll see. So they're different. So what we like to do is we like to call the ones over here the buses because they go along vertically. And then we call the ones in between here the rows because they're connected only along these ones. So these are the rows. And so you'll notice that they're numbered 0 to 60. It depends on the board. And they identify rows with letters. And so now that we've gone over that, you'll see the negative side they have over here marked by the blue, and the positive is marked by the red for this bus row. And now that we've done that, we'll be able to talk a little more about what you can do with a breadboard and Arduino together. And this diagram's really nice too to see the bus row. So the negative is all connected here, and the positive is all connected in red. And then these rows are connected only by the row through those holes. Okay. And now we're going to talk about the middle of the board. There's a center divider that runs down the middle. So the center divider here splits the board in two. There's no connections unless you physically make them from one side to the other. So there is no connection between this side and this side. And so if you do want to make a connection, you'll have to create lines across in order to connect those elements. And then after that, we're going to get a little into the Arduino IDE. And so what's an IDE? It's an internal development environment. It allows you to compile, so the code can be sent to the board, and then you can upload that code to the board, and then you can create new sketches of code. You can open existing code, and you can save your code. And so for the Arduino IDE, you're able to write your code. The setup runs once. So this is where you declare all your inputs, everything, all your pins, and then the loop runs over and over again. So it goes continuously. So it will run this one time, the setup, and then it run the loop continuously. So you have to verify your code, then you have to upload it to the board. So a verify is sort of like a check, make sure it works. Then the upload puts it on the physical board. And then you'll be able to save your code. You go to File, Save, and you can also open a previous code you ran before. And now that we've gone over the basic functions, let's talk a little more about this internal development environment. So we're going to have a serial monitor, and serial monitors are good because they tell you what's happening right at that instant. So if you said like print something to the screen, it will be printing continuously what it receives. So then the sketch editor, that allows you to basically write or edit sketches. So right here, the text console shows you what the IDE is currently doing and where error messages if you make a mistake. So here's where your error messages will be. And it will show you if it's uploading right here. And then the line number, you can enable this so it can number all your coding statements in order. And so that's basically how it works. So we'll get a little into it and how to create an actual code. And so for this, like I said before, the setup code runs once. So that's where you declare all your pin modes, everything. And then the loop is the code that you want to keep running over and over again. High in this code here, so high means the LED would be on in this instance. So the 5 volts would be connected to that pin, and low would mean the LED is off. And so that would be 0 volts is provided to that pin. The delay is sort of like the wait. It waits a number of milliseconds before sending the signal to the Arduino. So in here, this is 1,000 milliseconds, which is 1 second, the equivalent of. Digital write sends a signal to turn on or off a component, so you guys know. And so digital write is used with the digital pins. And if you guys remember, the digital pins are located on one side of the Arduino. So if I go back a few slides so you guys can see, on this Arduino here, we had the digital pins on the side from 0 to 13. And then the analog pins are on the other side called A0, A1, A2, A3, A4, A5. That stands for analog 0, analog 1, analog 2, etc. Okay, now that we talked about that, we're going to get into simple code. And so you guys know for a simple code, what I like to do is I like to start out with Blinky. So Blinky is a little nice code for the Arduino because it just turns on and off the LED. And so what we want to do is the mission is we just want to turn the LED on for 1 second, then off for the next second repeatedly. And so we're going to connect this LED so we know for pin 13. And so we'll have pin 13 here. And then we're going to have the setup code. So we're going to declare that LED, which we labeled for a variable. So our LEDs are a variable and it's connected to digital pin 13. And we're going to set the LED as an output since we want to turn it on and off. So that's going to be the result is turning on and off the LED. Then we're going to have a loop which runs over and over again. And so we're going to write to the LED. So when we write to the LED, we're going to tell it what to do. So when we write to the specific LED, we want it to go on. So we say hi for on, because on, if you guys remember, is 1, which we say is high. And then on the opposite end, if we want to turn the LED off, it would be 0. And so that would be low. And we're going to delay for 1 second. This is in milliseconds, so 1,000 milliseconds is in 1 second. And so what happens through this code, I'm going to run through it from step 1 to the very last step. And so here in the first line is a comment with 2 slashes, and then you can comment what you want to do. You can see they had lots of comments, 2 slashes, then they said their comment all throughout here. And so after they had a comment for the project title, they declared as a constant integer, so as basically variable that won't change, pin 13 is going to get assigned to LED. And so that's their variable. So they created, so the Arduino knows for the LED that's going to be connected to pin 13. And so that's created it in a space. So in 13 for that pin, it's going to be controlling the LED. Then for the pin mode, we declared it as an output for this LED because we're going to turn the LED on and off. So it's going to be bright and then turn off the next second. And so once we declared the specific pin mode in our setup code, now we're going to want to have it go on and off continuously. So that's why we go into a loop. So we're going to turn on the LED for 1 second, and then we're going to turn off the LED for 1 second. And we're going to keep rerunning that, so go on and off again continuously. And now that we've done that, I'm going to show you how it's connected to the breadboard. So for the breadboard connection, we have it connected to pin 13 down here. And the pin 13, the pin 13, like in our code, we said was connected to the LED. You see it's connected to a resistor here, and you're probably wondering why the resistor. You'll learn later on in 201 or 211 that you need some resistance in order to ensure that the current's not infinite. Because if we have voltage equals I times R, which is Ohm's law, this is, you might not know this yet if you're a beginner, but if we supply a specific amount of current, but we have no resistance, it's going to cause it to be infinite and it's going to result in an error here because we have to maintain this. So we don't want any error values to occur. So we're going to insert some resistance. So when we supply the current, it's going to give us a number for our voltage, and we're not going to have an error message or infinite current running through and going to cause potential damage to our LED. And so from pin 13, we have it connected to the resistor here, and then we have the LED, and then we connect the LED back to ground. So we basically start at the plus 15 volt, or the plus, and this gives out a specific voltage, each of these pins. And current, you can look it up so you guys know in order to have an idea of how much current each pin gives out. And I'm going to show you guys real quick. You can find that information very easily to know how much is being supplied. And so when I go online and I search up how much current does each pin give out on the Arduino Uno, so you guys know the 14 digital input output pins, it says each pin operates at 5 volts and can provide a maximum of 40 milliamps current. And so when we're looking at this, we'll know that there's 40 milliamps. So the current running through here, the amount of charge running through per second is 40 milliamps, and it's connected to this side, the resistor. And then it's going to go, oh, cool. Sorry, Nathan, that's pretty cool. Truth 658. Okay, so now I'm gonna get into it. Okay, so sorry, guys. I have this plus 5 volt source, which is giving 40 milliamps coming from this Arduino. And then I connect that in the breadboard to the resistor. And then I connect it to the LED. And so then we have our LED here, and then we have it connected to a ground pin. So we have our circuit entirely completed from this positive 5 volts to ground, which is 0 volts. And within this circuit, we have one resistor, and then we have our LED here. And so our LED is going to turn on for 1 second and then off for 1 second. And so our circuit is completed. We go from the positive to the negative. And so we have a complete closed loop within this circuit. And now that we did that, I'm going to go into, oh, and people in here for 220, well, good thing, sorry, for EE200, good thing you're at this meeting. And so now I'm going to go into a little more of how to upload the code. And so now that we got it inputted with our Arduino, we're going to have to upload this to the board. So now that we programmed everything, you have to implement it on the actual hardware. So everything here has to be implemented on that board. You have to send it over so it can receive it. So when you send it over, you're transmitting that data, and the Arduino is going to receive it. So you'll see this light start flashing when you transmit it from the computer over to the Arduino, because it's receiving all the data, all this code you put in. And so now that you'll know that, it's going to, when you upload it, you'll have to make sure you select the correct board. So we're going to be working with the Arduino Uno. So the Arduino Uno here, so you'll have to go up to Tools, Board, and then hit Arduino Uno. And then for port, it's the USB port on your computer. For mine, it was COM3, but it might be COM1, COM2. You just have to try it out and see which one, when you hit upload, works. And so after you select the specific board and port, you're going to verify the code, make sure it's written correctly, and then you're going to upload it to the board. And so there's a 4-step process. Make sure you have the correct board, make sure you have the correct port for the USB, verify that the code can get compiled so there's no errors in the code, and then upload it to the board. Okay, now that we talked about the process of how to do that, that sounds great. And you guys might want to see an actual example of how it works. And so I'm just going to show you a little video of Blinky so you guys can actually understand it, because I feel like an actual demonstration would be good to see. So the Arduino Uno, if you look up the Blinky for a video, what we have here is I'm going to talk you through this and just show you what he does. So I'm going to turn off the volume and just show you visually how he did it. So here's his Arduino board. And so the Arduino board, like I said, has the digital input output pins on this side and the analog pins on the other side. And so I'm going to have my spotlight here. So these are all the digital pins, 0 to 13. Then here's the analog pins, 0 to 5. Okay, now that we've done that, you're going to see they'll bring out the LED. And so for the LED, you want to make sure you have the correct polarity. So the smaller side usually is the negative terminal, and the longer side is the positive terminal. Also, you can tell the flat edge on one side of the LED will correspond with the negative terminal. Okay, now I'm going to get a little later into the video. So they actually plug it directly in, and they do that because there's insertion resistance in each of the pin. However, you can connect it to the breadboard, which I would prefer you do in order to get actual practice with it. So they define, as you guys can see up here, the pin 13 to the LED. They use hashtag define instead of constant integer LED 13. You can use either method. Then they had their setup code where they declared the pin mode for the LED as an output, because the LED, that's our output, what signals we're sending to it. And then they have the LED turning on, waiting for 1 second, then turning off and waiting for another second. And now, after they did that, then they're going to, you'll see verify. So they make sure it's verified correctly. All the code looks good. And after they verify, you see there was an error here. They forgot a semicolon at the end of the statement. So then they went back and then they re-verified. So they clicked it again, and then they uploaded to the board and they ensured that it was done correctly. And then you can see right here, it will turn on for 1 second and then turn off, turn on, turn off, turn on, turn off, because they have it connected to the computer as the power source. And so now that we have an actual visual aspect, it can help see you how the code is actually implemented. So now I'm going to get a little into the applications of coding from our previous lecture with the Arduino. And so you can use if statements, if else statements, while loops, for loops on the Arduino board. So all that Visual C coding you can implement in here. So here they have an if statement, and then they have the else. And so that's what they did. They used an if else statement. And I'm going to walk you through this code so you guys will know how it works. So they declared for the pin 13, they called it K pin LED. And in their setup code, they declared the K pin LED as an output. And they have a time delay integer, so they just have that as 1,000. So within their code, they declared, so what happens when it runs down is it creates the variable in memory. So in memory for the computer, it's going to have K pin LED to pin 13. And then they're going to have K pin LED as an output. And then we're also going to have the delay time as another variable. And the delay time is going to be set to 1,000. And that's going to be an integer, so you guys know the data type, it's an integer. And now that we have that in memory, we're going to run through this code in the loop file continuously, so over and over again. And what's going to happen is if the delay time is less than 100, then it's going to reset the delay time back to 1,000. So we started, our delay time was set to 1,000. So is 1,000 less than 100? Nope, it's greater than. So it's then going to go to the else because this is not true. So because that's not true, it's going to go to the else statement. So when it goes to the else, it's going to take the delay time, which we have here, which is 1,000, and it's going to minus 100. So that would be 900 then. And it's going to reassign that. So this equal sign means assign to. So it's going to reassign that to the value stored in delay time. So it's going to change 1,000 and then put in 900. So stored in memory, it's going to change it to 900. Now it's going to, because it finished that code, it's stored 900 now in memory. It's going to run the rest of it. And we can see we made the LED, we turn it on, and then we delay it for 900 seconds because that's our delay time in memory. Then we're going to turn the LED off and then wait 900 milliseconds. And then it's going to run the code again since it's a loop. So now is 900 less than 100? No. And so then it's going to jump to the else here. So it's going to assign now to this variable delay time 900 minus 100. So now that's 800. So it's going to assign 800 to delay time. So then it's going to go back in here, reassign 800. So now it's going to cross out that value, reassign it to 800 in memory. And it's going to turn the LED on, and it's going to wait 800 milliseconds. Then it's going to turn the LED off and wait another 800 milliseconds. And then it's going to run through that again, and you'll see it will just keep taking it down and down again. So we're going to get, it's going to be 900, then it will be 800, and then it's going to be 700, then 600, then 500, then 400, then 300, then 200, and then we're finally going to hit 100. And so is 100 less than or equal to 100? Yes, so that's true. So it's going to now run set delay time to 1,000. So it's basically now it's going to set it at 1,000 again. And then it's going to turn the LED on, wait a second, and then turn it off. So the LED will basically be changing values of how much delay there is in between. So it's going to change really fast, then go back up and then take a while to change again. So that's how the statement works here for if statement. And then I'm going to go over to the analog pin. So I talked about this a little earlier. So the Arduino supports pulse width modulating, and pulse width modulating is shown by the diagram right here. It has the duty cycle, so 0%, 25%, 50%, 75%, and 100%. 0% duty cycle means it's off forever. 25% means the voltage supplied is 25% of the entire cycle, so this is the cycle here. And then 50% means the voltage is supplied for half this cycle. 75% means the voltage is supplied for 75% of the cycle. And 100% mean that the voltage is supplied for 100% of that cycle. And so the pulse width modulating is noted by the tilde. And you guys can see right here, we have a tilde with pin 3, pin 5, pin 6, pin 9, pin 10, pin 11. Okay, you can give the pins a value between 0 and 255. So this means 0 volts and 255 means 5 volts. And the reasoning behind that, if you guys think about it, 2 to the 8 is 256 minus 1. That gives you, because if we do 0 to 2 to the n minus 1, that would be from 0, and then 2 to the 8 minus 1, that would give you 255. So that's just based on a binary. So the number of bits in here would then be 8 bits. So pretty interesting just how that number came into being. Okay, cool loop fact, but all you need to know is that 0 corresponds with 0 volts, and then 255 corresponds with a 5 volts. So if you want 2.5 volts, just take a number in between. So that'd be like 127. And 0 means that it's 0 volts, and 255 means it's 5 volts. And so you have to do this though for pulse width modulating with analog right. And the ratio of the on time, so when it's actually on the voltage here, is known as the duty cycle time. And so what we say is if it's on half the time, it has 50% duty cycle, and it will allow you to adjust the power output because how much voltage is being supplied to the output, because power is equal to voltage times current. You'll learn this in EE 211, and the amount of voltage outputted times the amount of current going through. If we know the voltage, how much is actually being outputted over this cycle, and we know the current by the pins is 40 milliamps, we can find the amount of power being dissipated by that specific output. Okay, now that we know that, we can talk about analog versus digital pins. Analog, remember, it's like me talking an old analog clock with the seconds hand. Digital is the discrete intervals, so ones and zeros. That's basically what you need to know. So what we like to do is for analog signal, it can be any value, can change consistently. The digital is set between high and low. So the ones and zeros, this is what it usually looks like, where analog is this waveform. And so the Arduino has a built-in analog to digital converter. So you can change the sound wave to a digital sound wave, sort of make it look like that original one. And so it's pretty cool. What you can do with it is for the analog to digital converter is it allows you to obtain the value of the analog signal using the analog read pin. You put your pin number in here for the analog read, and it will take that and return a digital value from 0 to 1023. And so you're probably wondering where 1023 comes from. If you take 2 to the 10, you get 1024, and then minus 1, since you include 0, that gives you 1023. So n equals 10 n bits. So you guys know. So we have 10 bits in here because n equals our number of bits. And now we know that the default reference value is 5 volts for the Arduino and 3.3 volts they have also as the output. You'll see on the Arduino, it can supply both outputs, 5-volt pin, and it also has a 3.3 volt pin. And so then there's also projects you can find, which is pretty cool using Arduino. I know at the end of E186, Leo requires you to do one. This website here is really helpful. I'm going to drop it in the chat to just get some inspiration from. And I'm going to show you guys right here. You can find all these different types of projects in order to know how each one works. And you can also consult the Arduino book and reference it in order to have some basic understanding of the Arduino. And one cool project we had by a student is he created a piano. It was keto, so let me pull it up real quick. He had a few images, and I don't know, he's not here right now, but I'm going to just talk about it a little. So Keo was a really nice, he's the other mentor, he can't make it today. But what he did for his project is he just had push buttons, and those would be inputs to the Arduino. And with his push buttons, he was able to create this piano board because when you push down on the specific key, it would trigger that push button and send a signal to the Arduino that that key was pressed. And then he would have a buzzer here, which would give out a sound. So if that specific button was pressed, then that sound would come out. So it's a cool, easy project you guys can do in order to have a better understanding of how the Arduino works and the actual projects you can implement with it. And now that we talk about that, so you guys know, next meeting, I'm going to be going over digital logic and how all the specific gates work for your EE201 class. So you guys have a good, solid foundation of these concepts. And there's no materials required for that one. And that will conclude the basic overview of the Arduino. So you guys have all those foundation requirements met. And if you have any other questions, you can stay behind. I know Nathan had a few on 201. But I'd like to thank you guys for coming and have a nice rest of your week. And we'll see you guys next week at 3 p.m.